Right. Uh, Hi friends. Let us continue the session. Okay. Let us continue the session of a drug metabolized in phase 1 by CYP450. Right. So I've already discussed about the different types of CYP450, where under family 1, family 2, and the family 3. So if you observe carefully, you can remember this, okay? One alphabetical A is one, so one A2, right? It's very simple. After A, after one, two comes, right? So CYP one A2. Next, we have got something known as B, C, D, E. Under this B, you got something known as B6. C, you have C19, C9, 19. D, you have D6, E. And cyto CYP 3, you have it. Now, if you look into the examples here, okay, the examples here. So, the first one, CYP 1A2, we have a paracetamol and you have tacrine and theophylline, right? So, this paracetamol, tacrine, and theophylline, they are metabolized by this CYP 1A2. Now, how do you remember this? Okay. So, if you look into this, you can just observe this rain. It's raining. Okay. And it rained so heavily, you became wet and you got fever. So, you took a paracetamol. So, tacrine, paracetamol, and it is theophylline, fill, right? So, now your cupboards are filled with paracetamol. So you can just remember like okay. And the second thing written here is CYP 2B6. How do you remember this? Okay. And you have got something known as cyclophosphamide and you have methadone, right? So you can just remember this as B, okay? So you can this cycle of nothing, you got a cycle, right? And this is cycle, okay? Cyclophosphamide, right? You met methadone, right? You met your girlfriend, right? At 6 a.m. So if you look at this CYP2B6, you have cyclophosphamide and methadone. And the next thing written here is CYP2C9. And the examples are phenytoin and warfarin. How do you remember this? So if you look into this CYP, you know everything's 2C9. Okay. Now you need 9, you need to remember, right? So if you observe carefully 9 and if you write this 9 ulta, this is 9, okay. And if write ulta, it becomes P. So P for phenytoin, right? Phenytoin. And you have, and this is war, right? Warfarin, phenytoin, warfarin. So that's the point you need to understand. And this is an important question. It's written here. And warfarin and phenytoin, it is metabolized by CYP2C9. Next, you have something known as same thing C19 now. Okay. Now C19 and the drugs are omeprazole, right? And you have clopidogrel, okay? Omeprazole, clopidogrel. Now, we have a few important points to understand here, right? So it's written that omeprazole and clopidogrel, if given together, right? So this is a omeprazole drug, right? And this is captopril, okay? Suppose if you give both the drugs, okay, if given together, and you need to understand the both competitively inhibit each other because you got a two substrate and one enzyme. And what is that enzyme? That is CYP2C19. You understanding, right? So, two substrate, one enzyme. Thus, the omeprazole thus decreases the effect of clopidogrel, right? Most common enzyme required, that's fine. So, at the end, you need to understand. Say, example, you have a patient who had MI, right? And doctor, right, suggested, like along with that aspirin, all that, we have clopidogrel, right? Now, say example, this patient has gastritis, right? And keep in mind, for such patients, you are not supposed to give omeprazole. Why you are not supposed to give omeprazole? Why? Why? Yes, because these two drugs inhibit competitively, and this omeprazole decreases the activity of, right? If you look at this, decreases the activity of clopidogrel, right? It decreases the activity of clopidogrel. If you start giving the omeprazole to such patients, he can have a second attack. So you need to be careful. Okay, right. Now, the other important points here is you can see D6. D6 and this metabolize psychiatric drugs, opioids, and beta blockers. Right? So you can look into these psychiatric beta blockers, opioids, and how do you remember this? Okay. So it's very simple to understand. This you gotta P. If you draw one more O, this is O. Opioids, it became B. Beta blockers, second. You just remember, right? How you remember is not important, but remembering is important. Under the family two, you have a next last subfamily that is E1. Then how do you remember this? Okay, the name itself tells E for N-fluorine ethanol, right? So that's how we can remember, right? That's how we can remember. So now, and the next point written here, it's written that CYP3. Okay, now let's go into the final family that is 3A4. Okay, after 3, 4 groups, it metabolizes more than 50% of drug. Now they can ask an important question that is most common enzyme required for the drug metabolism is, what is that? It is CYP, third family, A subfamily, 4 isoform. Then you got a drugs like rifampicin, you got a digoxin, right? All more than 50% of the drugs, right? So they can ask you this question. No, that's all about the phase one here. Okay. Now we need to understand, okay? We need to understand what actually happens in the what phase two. Okay, what actually happens in the phase two? Now, in the phase two, right? In the phase two, uh, let's I'm looking for something else. Okay, in the phase two, you have a drug metabolized in the phase two, and the first thing written here is you got something known as glucuronidation. On the drug, you have atazanavir, irinotecan, and you have estrogen. And you have something known as acetylation. Mnemonic, there's something known as HIPS, hydrolysine, isoniazid, procanamide, sulfonamide, dapsone. And methylation, 6 mercaptopurine, methyl sulfation, that is sulfation, that is steroids. So let us understand what is it trying to tell us. Okay. Now, if you observe carefully, you have The first most common. Okay. So the first is glucuronate. See this glucuronidation, right? Glucuronidation. So now say example, right? We have another important points to understand. See, right? So it's not in this point. Now say example, right? This is a stomach, okay, and you have got a liver here, okay, and you have taken the drug, okay, you have taken the drug. Now you have taken the drug. Now what happens is important. Now you have taken the drug, okay. The drug goes into the stomach, right? From there it goes to the intestine, all that. To the enterohepatic circulation, it goes into the liver. Now, what happens in the liver is phase 2. Now, in this, we have an enzyme known as glucuronidase. So, whenever you take the drug, okay, it undergoes the phase 1, it goes into the liver. In the liver, you have an enzyme known as glucuronidase. So, they both this glucuronidase act on this drug. I need to understand what is the function of this glucuronidase. It is an enzyme that hydrolyzes the glucuronide. So you can look into this. This is a glucuronide. It hydrolyzes, okay. So it has gone out. Only the rest of the structure is left, right? And what are the examples? The examples are atazanavir, you have irinotecan, and you have estrogen, right? So these are the basic things you need to understand. Now you have a next important point written here is next basic point. What is the next basic point if you look into this? So I can you can look into this. Okay. So now it's written that atazanavir and irinotecan are contraindicated in Crigler-Najjar syndrome. Right? Glucuronidation is affected in this condition. Atazanavir can cause Steven-Johnson syndrome, and irinito can cause toxicity. So what is it trying to tell us? Okay. So you have a drug known as atazanavir. Okay. Now this atazanavir and irinotecan, we are not supposed to give in the patients of Krigler Najjar syndrome. And why we are not supposed to give? Because in this Krigler Najjar syndrome, it is it is a rare disorder. Remember that, okay? It is a disorder where there is a decreased glucuronidation, right? Now, first of all, in these patients, there is a decreased glucuronidation, right? Decreased glucuronidation. In such patients, if you start giving these drugs, where the phase 2 activity, for the phase 2 activity, they need an enzyme glucuronidase. So, in such patients, you're not supposed to give this atazanavir and irinotecan. Understood, right? So, and then next, if you let us discuss the estrogen later. But we need to understand there are some drugs where like hydrolysine, okay, you have like they have given the mnemonics HIPS. So H for hydrolysine, I for isoniazid, P for procanamide, S for sulfonamides, and D for dapsone. These drugs, okay, these drugs, they undergoes the phase 2 reaction by acetylation, right? So you can look into this. This is an acetylation drug. Yeah, acetylation. Now, in this acetylation, right, you can look into this. This is an acetylation. Now, there is what do you mean by acetylation? acetylation, where the you can look at this acetic acid is involved, right? CH3 is involved, right? So this is involved, the functional. We just remember, okay. And the next important is methylation. Now, what happens in the methylation is important. So, in the methylation, if you observe this methylation, where does it go? Where the CH3 group is attached. Okay, that we'll be discussing in further session in detail. For time being, we need to understand you have a drug. Okay, now what happens to the drug? So I don't know why on this drawing tools. Okay, this is another. Okay, so, so let me look into this. Okay, um, let me erase this. Okay, I don't know why it is. Stupid. Okay, it's not going to be like so. Correct. Now, if you observe this, this is the patient of Steven Johnson syndrome. Now, why this patient, right? If you look into this, this is a Steven Johnson patient. This patient, okay, this patient, what happens to this patient? So,